Okay, this video is the second part of the review video for Chapter 8. I'm going to be talking about the second component of Earth's climate system other than the sun, called the hydrosphere, and touch on things like thermohaline circulation, feedback loops, and the albedo effect. So as mentioned, the hydrosphere, it includes all liquid water, water vapor, and ice on Earth. Now, water is really important to Earth's climate system because it can absorb and store carbon dioxide from the atmosphere, which helps to moderate the temperature. The other thing that water has a really cool ability to do is store and hold on to thermal energy, even more so than the Earth's crust. So that makes large bodies of water very big heat sinks, and therefore that's where we can see large bodies of water having an effect on climate or climate zones for land near them. One of these phenomenons we can kind of see near us, usually London gets it more, and that's lake effect snow or snow belts. So here's an example of, I believe this is Buffalo, and we can see how that air that passes over the body of water in the winter, the land is colder than the water, so the air is picking up warm, moist air as the air travels over the unfrozen lake because it's still holding on to that thermal energy from like the summer. And as the air passes over the land, it cools down, and cold air stores less moisture than warm air, so it falls as precipitation. So that's where we get those large snow belts. And we can have areas that are definitely in the snow zone getting tons of snow, while areas just around them like Windsor getting very little. The other thing about the hydrosphere is, like the atmosphere, it's a fluid material. Water is very fluid. So it's another way that energy can actually be transferred from one area to another. Now, movements of water currents are called thermohaline circulation. Thermo for temperature gradient, and haline because of the salt concentration. Now, sometimes these thermohaline currents are driven by air currents, by prevailing air currents, but a lot of times it's driven by the land masses, and they get forced around the globe. So here's just an image from the textbook showing the major thermohaline circulation. We can see how we have warm water coming up from the equator, across over to Europe, and it starts to cool down as it goes further north. And if we look at an area nearby there, which is England and the United Kingdom, again, as that water cools down, the air surrounding it also is cooling down. And like I mentioned before, cold air holds less water than warm air, so we would get a lot of precipitation events there. And we know that England and United Kingdom are known for having rainy weather. So the other thing that we can see with thermohaline circulation is kind of short-term changes in our climate as well. If any of these currents shift, we can get a short-term change or an effect on climate. And one such example that occurs every 5 to 7 years is called El Nino, and that's a reoccurring change in Pacific winds that make the ocean currents change direction off South America here. And when that switches, we get a change in the weather patterns in not only just in South America, but we even see those differences right through all North America. Now, the hydrosphere doesn't just transfer energy. If we look at just one component of the hydrosphere, and that's ice, ice can actually hold records of climate. We've seen how ice cores are considered proxy records because they're really good at trapping levels of atmospheric gases and can give us clues about our climate. And ice holds another really important key. Ice is really reflective. It can actually reflect a lot more of the sun's energy than land. Now, when a surface reflects energy, it's actually given a measurement called albedo. So the albedo is the measurement of how much the sun's radiation is reflected by any surface. So if we look at the albedo for ice, it's actually 0.75, meaning that it would reflect 75% of the sun's radiation. And if we look at something like just a grass surface, it only reflects 20% of the sun's radiation and therefore has an albedo of 0.20. Now, the reason why I'm mentioning albedo is there is something known as the albedo effect, and that's where one of the most important positive feedback loops that occur in Earth's climate system. Now, you're probably wondering, what is a feedback loop? Well, a feedback loop is a process that will help, or the result of the process will actually influence the original process again. Now, there can be two different types of feedback loops. Positive feedback loops basically feed back into the system to continue to increase it. Now, it can be continuing to increase it. For example, more water vapor leads to higher temperature, and therefore, if we have more higher temperatures, we're going to evaporate more water and have more water vapor. We can see how this cycle would build on itself. So this positive feedback loop is having an increasing effect. But we can also see a positive feedback loop that has a decreasing effect. The key about positive feedback loops is there's no control within the system. It seems to just go on and on and on forever. So there's no built-in control. Now, negative feedback loops actually, within the loop itself, there's something that causes a control or a decrease. So there's a built-in clause. They have more of a cyclical pattern. So I'm just going to show you a couple feedback loops, and we can go over if they're positive or negative. So as I mentioned, the albedo effect is one of Earth's most important feedback loops. So if we look at ice on the Earth's surface, remember, ice can either have a cooling effect or it can actually have a warming effect. So the more ice we have, the more energy is reflected off the surface because ice has a high albedo, the cooler our temperature gets. And if our global temperature decreases, well, it's going to produce more ice. So this is a positive feedback loop that would result in the cooling effect of our climate. Now, when we have less ice on the surface of our Earth, more energy can actually be absorbed by the surface, less is reflected. Therefore, more thermal energy is going to be given off, and the warmer our global temperature would get. As we get warmer, we're going to get less ice. So again, this is another positive feedback loop, but it's resulting in the cooling effect of our climate. So those are the really important aspects of the hydrosphere.